All right, let's look at chapter 10. It's a variety of small stuff in this chapter, but not really as big of a thing on anything. If you look at their list of key terms, it's a few protocols that they mention to you, and that's pretty much it. And actually, we've talked about most of this stuff already in the midst of other things. So we are on the application layer on the TCP IP model. We're on the top layer. On the
OSI.
On the OSI model, I was thinking I just mixed it up, but it really hadn't. On the OSI model, we're on the top 3 layers with the session, the presentation, and application. So they're looking at those. They do a brief little mention about the session and the presentation layers. And that presentation layer, the mention on, is concerned with formatting the data into a form that's recognized by the destination device. Compression is going to occur here. So if you're going to compress your data, that's done on the compression layer, on the presentation layer. Okay, so compression would occur there and decompression obviously also. So that gets it into the correct format, and then encryption is also going to occur here. Okay, so you'll have that all occurring there. And that's the major things that's occurring on the presentation layer. Session layer is going to be concerned with establishing the conversation with the other end and maintaining it. When I was taught it, that the instructor said to sort of think of the session layer as the secretary. Okay? That establishes a call and then ends the call, but once the call is made, passes it off to somebody else that talks then, and then gets passed back to them and they conclude it. So, secretary in terms of high-level executives and stuff, not our level. And that's basically all they tell you about the session and the presentation layer. So then they go on into the application layer. They mention here a number of the protocols on page 505 that are on the application layer in terms of, again, back to TCP IP. So they sort of combined it all together right here on their presentation. So HTTP is brought up again. You know that one already. We've talked about it already, and that's the one you use the most anyway. And then HTTPS, so that you're aware of both of those. You know the ports are 80 and 453 for them. Simple Mail Transfer Protocol is the protocol used for what? What? On email. It is used for email. What about email?
To send it. And
To
for
send
servers to
email.
transfer back and forth.
So it's used to send email. Port 25. POP is becoming less and less used. It's port 110. Again, it's an email one. And it's used for receiving, but it downloads all your messages to the client you're on. Okay? So you're seeing less and less of that. IMAP is the one that's being used instead, and that it allows you to work with it on the server, which is what you're doing with your Gmail, your Yahoo Mail, or just about any of the email systems out there now are using IMAP. Okay? That was with the Gmail and the Yahoo Mail and a couple of those. That was a big advantage for them initially when they came out, was they went to the IMAP first, and then a lot of the smaller ones were slow on going there. Now what it is that a lot of them have just moved their email systems over onto Gmail or Microsoft or Yahoo and just let them handle it, but it's still under their domain. Email here at the college is no longer done by the college. It was till a couple of years ago. And then that they put it all over on Microsoft servers and let Microsoft handle it all. So it's still under our domain. They mention about boot P here, which really you're not going to see used much out there as a host configuration protocol, as they've got in the group of. It's an old one of allowing you to have machines that you didn't have the information on them, that you could have a diskless workstation and boot the machine from elsewhere and have the operating system sitting on another one. You're doing it next door and in most of the rooms in the building now, but they're using virtual machines to play off of. And that you're seeing less of that you're seeing DHCP used now to do on it, because actually what they were doing was that they got the information and worked with DHCP, supplies all the information, will actually point to where to go get the information to. So DHCP has succeeded there. DHCP actually with IP version 6 is still there, but it declined some in version 6 also, okay? But boot P they mentioned, but you don't see boot P really used anymore. That you're going to see DHCP anyway, but for some reason they keep on, not just this book, but everything out there keeps putting an emphasis about boot P, even though it's pretty much an obsolete protocol out there. Okay. Then they talk about the file transfer protocols. They've mentioned about FTP, which we told you to use 2 ports before, uses 20 and 21, and that's to do your file transfer, but it's doing a connection oriented, and so you know it arrived on the other end. They also mentioned TFTP here, which uses port 69, which is connectionless, but you're not going to hardly see that one used. The main place I have ever seen TFTP used is for connecting to the routers or the switches, where you set your router or switch to get its configuration at boot time using FTP, which is a setting you can do in the router and switch on the Cisco ones. It goes and gets it from another machine, connected to it, and uses TFTP to do it. Well, the machine it's pulling it from is directly connected. It's not going across the network or anything, so it doesn't need to have a connection protocol on it, a connection-oriented protocol to make sure it got there. It got there because their two are just plugged in right there together. And that's the only place I've really seen it, but it does utilize less overhead. Normally, if you're going to have to transfer files, you're going to use FTP. They come back and talk about the client-server model and peer-to-peer networks and applications, which if you go back, I think that was chapter 2 when we talked about them before, way back in January. That client-server says we've got a larger machine there that's a server that we're putting most of our information on, and then the clients pull the information from that server. The server could serve as a server in several different ways. It could be a data server for just keeping data out there. It could be a security server where you keep all the security information on the server instead of on the clients, which quite often is the case, those first two. You could have other types of information kept there that you're wanting to centrally keep it, okay? So the client server is there in terms of that. Peer-to-peer networks is where you've got all of the machines are equals. Security is done on the local machine. If you want to change the password for all your machines, you got to go to machine. Client server, you just change it on the server and it's changed everywhere. Okay? Peer-to-peer, all the machines are equal, and each machine is responsible for its own security. You will see actually both models used out there and at the same time, because it may be that he wants to share a file with him sitting in here. They could just do a peer-to-peer and just transfer it across. that he could just go in, share the file, and he could access it on his machine. So I'll follow on that while we're still running on a client-server environment. So you can run peer-to-peer within client-server, okay? At the same time as client-server. And you will see that happen. Peer-to-peer applications are applications that share information all around, but they're not using a server on it. Each end device has its rights on it and sharing. Sometimes for some of you that go and get files out there off the internet or get games or some music or such things, and music had big fights over for years, videos are still having some fights on it, where you can go out and get something and it doesn't come from any central spot, but it's whoever decided to share it out there. You're using a peer-to-peer application type approach. You've got peer-to-peer applications out there too, where stuff is shared around too. Some of the games some of y'all play, where you're playing the multi-user games, you're playing them in a peer-to-peer approach. So that if you're on there, you're on there, but if you're not, nobody knows about it, and that each machine is separately connected. Y'all aren't going through a central server that plays the game spot on it. That everybody's machine is all part of it. Does that make sense? So, but you'll see that quite often out there. So they mentioned several things out there on peer-to-peer applications. And that, like I say, sharing some things out there has been lots of controversy and continues to be, and the music industry, the video industry has carried on and fought all kinds of stuff that's tried to set stuff up out there, and when it's been done in a peer-to-peer, it's exceedingly hard to shut down because everybody that's on there has actually got the rights running the thing. So you can't go say, let's shut this one machine down, shut it all down. We shut down Mark's machine, it doesn't phase the rest of you. And if we go and shut down Kevin's machine, then everybody else keeps on working and Mark can pop back on and so on. And there's no central spot. If it was an client server approach, which is what most of your stuff really is out there in a lot of cases on the internet, you go shut down a machine and you shut down whatever it is. Okay? But if it's been developed in a peer-to-peer model, there is no one place responsible for it. And there's no one place you can shut down. So it makes it extremely difficult to do, which took a long time for those industries to figure that one out, because they'd go filing suits saying, shut down this machine, and it didn't make any difference on all these people sharing stuff anyway still. They talked some about the web and email protocols, but I've really talked about those before and even just talked about them there for a moment. They do talk on the HTTP and HTTPS that there's a GET, where it's actually a GET command. When you type in the address and request a web page, it sends it back with POST. And if you're going to upload resources through the web server, which you can do FTP through your web server, you can actually do email through your web server, etc. Your web browser. Your web browser will do a lot of things for you, because you can do, instead of HTTP, you can do FTP : and tell it to connect using FTP to a page. You can also tell it to do email and send a message to somebody doing email : and then their address and then subject and so on, and do it actually in a command line through your browser. So if it's moving resources, it uses a put command. HTTPS is going to use SSL, which is a secure sockets layer, which encrypts the information that's sent across. On some of your browsers, it appears as a lock up there on your browser line. On some others, it appears slightly different, but it will tell you that you are doing HTTPS, which says you're using SSL, which means your stuff is encrypted. So somebody can't listen in, have grabbed the stuff, packets coming across, and get the information you were sending. It's been encrypted in there. Okay? Email, they talk about those. I've already told you all about that. So I don't think I really need to tell you anything else about IMAP, SMTP, and POP that I've explained those to you already. DNS, they didn't talk about that one. We talked about DNS already in previous chapters, and then I went a little deeper than what they did on it when it came up. But with DNS, remember, you're typing in a domain name when you go to get a web page. You type in www.dwightwatt.com. That's not going to work across the internet. So DNS is going to find what the IP address is for that domain name, and then the request gets sent out to my web server using the IP address, not using dwightwatt.com. Does everybody follow on that? So when it actually goes out there on the internet, dwightwatt.com's got nothing to do with it. It's using the actual IP address, which is the way things were before the web, and that was a big advantage of the development of the web, was with DNS, besides the HTTP protocol coming along. But big thing was we could use names, not numbers, and that made it useful for most people. Because the only people that before that point, everything you had to put in the exact number address for it. You had to keep a list of numbers around on it, and the only people that used it were the geeky ones. Okay? Everybody else didn't know what in the world. They heard rumors that there was a way stuff got shared out there somehow with computers, but didn't know anything else about it or how to do it. But with DNS and HTTP, with the web pages and DNS allowing us to do names instead of numbers, it became something usable by the whole world. You're going to type in a domain name. The computer then sends a request to the domain name server requesting the IP address. Actually, there's a step before that. They skipped a step here in a little. It's going to actually look in its own little table on the machine and see if it knows the number already. If it doesn't, then it will send it to the server. And when you create, as you set up your network connection, you give it your IP address, the subnet mask, and you actually give it what the address is for the DNS server at that point. Usually that DNS server is your router modem. Okay? It works as a DNS server also. So here's another place the server gets to play in, that you can have a DNS server too. Makes a request to that server. If it knows what the IP address is, it sends it back to the client. If it doesn't know, it has got a DNS server listed in it from its addressing information, and it makes a request to that one. It will work for about 4 layers up that way, and you'll end up because then it goes to the ISP for their DNS server, or there are other DNS servers you can have out there. So Comcast is going to give you a number for their DNS server. Okay? There are others you can use too. You don't have to have it point to the one from your ISP. Google supplies a couple of them out there that are big DNS servers that people use, and they've set up and have reliably worked for years. There's one at 4.4.4, that's 4 fours. There's one at 8.8.8.8, again 4 8s. Okay, that Google has out there available to you. If your DNS server that you're connecting to fails, you can actually go in and change your DNS address and then actually keep on working them. Some of the times when people say the internet's down, that they can't get to anything, but yet they're showing activity, on their little activity monitor, and their box is lighting up correctly and everything. The problem isn't their connection to the internet. Their problem is the DNS server that they connect to is down. And I've caught that with Comcast happening a number of times on me. So I don't even use Comcast DNS server anymore. I connect to 4.4.4.4. Okay? But when I'm not able to get any pages, that's the first thing I'm going to do is go change the DNS server address and see if it works. If the lights are lighting and that it looks like I've got connectivity, but I just can't get any web pages. Does everybody follow on that? And then at that point, if that's the problem, you're back to work. Everybody else that's sitting there on the same ISP as you is going around saying the internet's down. And you're still using the internet through the provider that they're all saying is down. It's just their DNS server died. Okay? There's 5, I think it is. It could be 7, but it's about 5 root DNS servers in the world. And they've got them scattered a few different locations around the world. I think it's IANA runs them. And that's where, if you register a domain name, that's where the registration goes first. And then when somebody requests the page from your name, it's got to go all the way up that layer to find it, and then everybody remembers it coming back down, so it'll take harder the first time to get to the page. It's also why they'll tell you if you register a domain name that it may take 48 hours before it becomes useful. It's got to get into that root server. They got to update their database. As soon as they update it, then it's a question of your machines all going back to the root to check for it first time. Typically, we're all going to the same web pages. Okay? So it doesn't have to go to the root to find the information normally. A few years ago, I think it was 2 years ago, a couple of years ago, some people, actually students, someplace in the world, not where they were, sitting through the same lectures you're listening to right now, got the brilliant idea, because they didn't listen to the whole thing, of, wait a minute, if we do a DOS attack on the DNS servers, the 5 of them, we'll shut down the internet. Okay? Because that's where is the main place all the names and addresses are kept. So if we kill that, nobody will be able to get to any web pages. So we'll effectively have killed the internet, right? Except they didn't listen to the whole thing. I assume their instructor told them, but maybe the person forgot to tell them about the whole thing, is most of the time when you make a DNS request, it never goes to the root server. That the local DNS server or one of the 2 layers above it are going to already know about that domain name and return an IP address for it. Okay? So it's only the latest names that haven't gotten scattered all out there would be unknown. So when they did it, they successfully shut down those 5 machines. They weren't accessible because they did a DOS attack on a distributed, that they did the denial of service attack on it, and probably was a distributed one, but whether it was or not, they successfully shut them down. Most people in the world never had any idea anything was wrong with the internet. The ones that did it had to have been greatly disappointed, because there they thought they had shut down the internet and the world kept right on humming along as if nothing had happened. The only thing that it impacted was if Kevin had just bought kevinstropshire.com and registered and put his page up there right then, that nobody could find his page because his name hadn't distributed out across the internet. But everything else, everything knew about. Everything kept right on going to CNN, that when Mark put in CNN.com, no problem, every DNS server in the world knew what the IP address for that is, so he could keep on doing that. John could continue looking at dwightwatt.com because my name's been distributed on down through the systems well over time, etc. It's just Savannah could not get to kevinstropshire.com that he told her was his fabulous page. I forgot to put it on vibrate. In case y'all didn't figure that out. And that's all that happened because of it. So they didn't do any real damage out there. Okay? So it works up through to the root if it doesn't find it. So it's very seldom the roots ever even get hit by request. Does everybody follow on that? Because the others are building tables all the way down to the PC to remember. And so the only time it gets hit is somebody makes a request for an address that nobody else has gone to that address along the line up from them. Okay? Because you may well go to a new address that you've never gone to before, but probably someone else on your network or on your ISP has gone to that address also. Does that make sense? So it's not very often we go off to, we may go to different pages all over the place, but as far as domains that we go to, there's not too much of that. And that's the only times it's going to bump on up there is when it's got to go rebuild it on. So that's the DNS service. They take you through and show you that whole process there. They show you the format of it. They do mention to you about there are several different types of DNS records, which you will see this one once in a while. An A record is one that has an IP, and this is the records built in your DNS database that you've got out there. The A records are end IP addresses, so it tells you what the IP address is for a specific domain name. NS is where it tells you the name servers that it can use. Is that you this time?
Yeah, that would be.
4As is for end devices in IP version 6, which is like an A record in IP version 4. And then MX records tells you this is an email server. Okay, it's got no email servers versus regular servers. So those are out there. They mention about the DNS hierarchy, which says that our names have got actually give us to the country they're on, so that many domain names out there in the world end with a country name on it. The US, they don't end with a domain name with a country name on them, so that ours end in the .com, .org, whatever, because we invented the internet. Okay, so we used those names, and then when they went to when it spread out to other countries, we stuck country abbreviations on the end of them. So those are there. So you see those occasionally where you look at a web page that's from some other country of the world. So they mentioned about that. NS lookup. Just provides if you do NS lookup, it will go out, and it's a command you can use. You can do NS lookup and your domain name, and it will return the IP address for you. So it's doing what DNS does, but it's calling DNS and making a request of it. Because you don't do DNS as a command. That's not a command, that's a protocol out there. But NS lookup is the command that will go to DNS and find you the IP address. Does everybody follow on that? So that can, if you want to know what the IP address, if you want to know the IP address for dwightwatt.com, you could do NS lookup dwightwatt.com. And you don't need that first part of it, you just need the last two pieces of it, or three pieces depending, but you just need the actual name and the last name of it. Because the first part just tells you which server within that domain it is. So www is what we normally name our web server. But y'all have all seen where occasionally it's something else other than www on the front end of it. So that's what NSLOOKUP does. DHCP, which is Dynamic Host Configuration Protocol, I've mentioned that one to you before, but again, what it does is when your machine turns on, it sends out a request for addressing information. Because if you're using DHCP, you do not have a specific IP address assigned to each machine. So that when I turn this machine on, the first thing happens, or should, I'm pretty sure we're using DHCP here, it's going to make a request. It's going to actually send out a broadcast and say, I need an address from a DHCP server. And it's going to be a DHCP request. Any DHCP servers that are on the network, and there could be more than one, are going to respond back with an offer. And they're going to send it as a broadcast. Has to be sent as a broadcast because this machine has no address yet. So every other machine in here has to get that same message. They got the message came out from here. They get the message of the offer sent back. Does everybody follow on that? It's sent back to here, and this machine's going to take the first one that's sent back normally and accept that offer. Okay? However, if the DHCP server sends out an address that's already in use, Mark's machine's already got it. Mark's machine's going to send up a signal and say, I'm already using that address. Now, it shouldn't happen because the DHCP server is going to remember every address it has leased out. However, Mark may have put in a specific address in his machine instead of using DHCP, and nobody remembered to take it out of the pool at the DHCP server. Does everybody follow on that? And we can't have two machines using the same address. So if we're doing it through DHCP, it's going to catch it. So it's going to send out a request when it comes on, or discover. It's not sending a request actually. It's just announcing, I'm here and I need DHCP information. Now, DHCP could just give it an address, or it can give it a pile of information. They can also be reserved on the DHCP server specific addresses for specific machines. And so you can actually keep the naming and all kinds of other stuff on the DHCP server and keep none of it on this machine. And that it gets assigned to it when it comes on. Does everybody follow on that? So it does a discover. The server sends back an offer, both as broadcast. Okay? The client is then going to send back on the offer that was made. It's going to make a request to use that address that's been offered. Okay? Could have been that something else could have gotten that address in between, so the server could decline it, but more than likely it's going to accept it. And at that point, it will send an acknowledgement back and say, it's an acknowledgement, and at that point it says, use the stuff, and this machine connects in at that address. So there was a discover broadcast, an offer broadcast, a request specific back to the correct server. Okay, so that one goes as a uni command on it. It's just sent to the server, not as a broadcast to everybody. And then that server is going to acknowledge that, okay, I've added you, I've leased that address out to you. By default, it leases the addresses out for 8 days. Now you can change the settings in the DHCP server to shorter or longer periods that it leases them. You can actually set it to 0 days, which says it's a permanent lease. Okay? And you can lease them all out permanently. At the end of 50% of the lease time, the machine is going to send a request again back to the server for that address, saying, I want to keep using it. The server will send an acknowledgement back, and at that point it sets it again for 8 days to go. At 50% of that time, it sends again. If there is no acknowledgement comes back, the machine keeps on using the address, and at 50% again, it sends another request out. Is everybody following that? So 4 days it sends a request, 2 more days it sends a request, 1 more day it sends a request, 12 hours it sends a request. Does that a number of times. Now hopefully somewhere along there, the DHCP server is there online and replies and continues the lease. Okay? But the DHCP server could be offline. It doesn't have to be there during that lease period. It just needs to be there at the beginning and end. Okay? If the lease runs out, then this machine loses the address, and it's got to get another one and starts requesting again, going through the discover process. Okay? But normally, it should renew at 50% of the time. It's just like if you have rent an apartment. You've got it rented for a certain amount of time. After a certain way through that lease, the landlord's going to ask, are you going to keep on keeping the apartment or not, and then extend your lease for it. Y'all follow on that? But they don't necessarily do it at 50%. They usually do it down towards the end on it, or that you've got one where it's just month by month once the initial lease runs out. Y'all follow on that? So it's the same approach, and it's leases is the term for it. It is leasing that address. And you can go into the DHCP server and say, stop the lease on these addresses, and it revokes them at that point. File transfer protocol already talked about. SMB, they mentioned that one to you. That will help manage your devices and stuff, and that you can use as a messaging system to manage the devices out there. So that one's there for the control of and controlling people getting to your files on your machine and stuff through a server. And so you'll use SMB for that. And I just turned the page and discovered the paper turns blue. So that means the end of the chapter, right? So that means we made it through chapter 10. Questions on that?
So that's what the renew lease button is that you usually see on like phones. It's just sending requests.
So if you do an IP config /renew, what it has done is it's sending a request back to the DHCP server to renew that address. If you do release, at that point you've dropped the addressing and you've got to then rebuild it on. So that's what those / commands on the IP config command do, is they're actually communicating with the DHCP server. Correct.
Does like your computer know it's the HCP server at that point, or is it still doing a broadcast?
No, at the point when you do that renew, it knows which machine it was connected to. It remembers who the server is, so it just sends it specifically to that server. Okay? It's not sending to everybody else because it knows who leased it to it, so it sends directly to
So the
them.
server says, hey, this is me, when it sends back something.
Yeah, because it's sending back a regular packet, so guess what? On that packet, it's got
Source,
the source address, so it knows who it came from. Okay? It's got the source and the destination. The broadcast packets, remember, that's got sent out addresses of 0.0.0.0. It used quad 0. Remember, we said it's called quad 0 also. That when it's sent it, or looking in the physical address that it did the all F's. Okay? Actually, I just told you wrong on that. On the broadcast, it sent you all. It sent you the 255, 255, 255, 255, 4 255s. okay? Which was all binary ones for the address. Quad 0 actually says this is our default gateway. But you can go in and do on IP config. Remember, if you just do IP config, it's going to tell you your addressing information. IP config/all gives you a bunch of information about your configuration. If you do IP config/renew, it will proceed to request to renew your address right then. What it does at halfway point. So you can separately do it yourself. If you do release, it says, I don't need this address anymore, and it drops it. Okay? So, and there's a couple of others. If you do ipconfig/? It will give you all the / options you can do on ipconfig. And you can do a bunch of different things. You can actually tell it to get a new one also, to go and get you a separate different address. And you need to do that once in a while, that they'll get goofed up out there. Somehow, Mark did put in that address on his machine, and so we need to get a separate address. So we don't want to do a renew on it at that point. We're getting messages about our address is already in use, there's a duplicate address. Well, at that point, we need to tell it, just send us a whole new address. Throw that one out. It doesn't work. And that does happen once in a while on a network. I have had to do that a few times. Go in and just tell it to start. The other option is turn the machine off and on, because then it'll get a new address anyway there. So if I'm talking to somebody that's what I think needs done, that doesn't really know about computers, I'm not going to tell them to go find command prompt and then type IP config / whatever. I'm just going to tell them, go down there and hit the power button and tell it to restart, and that'll take care of the whole thing for them anyway. It goes out and does the whole process, but it comes back up. And it may well clear out something else that's in the memory causing a problem with them anyway. Because even though the Windows and stuff has for you pretty much now that they really don't intend for you to hardly shut down a machine, you do need to shut a machine down occasionally. Servers now quite often will run for years without being shut down. I've literally seen servers that have ran for 4 or 5 years, never being shut down in that time period. Although my bid is usually it probably wouldn't hurt to shut them down once every few months or a year, just to reset everything in there. But you got plenty of servers out there that have run for years, but you're looking at server operating system versus the client, and the server one's built for a heavier load on it. The client one, if you don't shut your machine down normally, I would recommend to you at least shut it down once a month. Go through a restart on it and let it do stuff at that point. It'll do some updates for one thing, but the other part is on your client one that quite often that you've got to do a restart when it does updates anyway. The server one, literally let them sit. All right, questions on 10? All right, Wednesday. Let's speed up the process a little bit here. And let's go ahead and do 11 on Wednesday. On Thursday or whatever. Okay? The second day of this week. Okay, so on Thursday, let's remember I got 3 classes on Monday, Wednesday, only y'all on Tuesday, Thursday, so y'all are the odd ones. So on Thursday, let's do chapter 11, and then that gives us Monday and Wednesday to work on cabling next week. Tuesday and Thursday to work on cabling next week. Okay? So we follow on that? Because if we put off chapter 11 till Tuesday, then that means we've only got effectively Thursday to get the cabling done. And if anything odd happens, we haven't got any spare time built in on ourselves. Okay?
Are you keeping due dates the same?
Yeah, test due dates still be the same, so 10 will be due next Monday, and that is Monday. And then 11 will be due next Friday. But I will try to go ahead at least on Thursday, if not before, I may do it beforehand. Try to go ahead and open 11 up for y'all anyway from now, okay? So somewhere in the next day or so, I'll try to get 11 open for y'all. And that way you don't have to wait till Monday to take it. Since we'll go over it Thursday, that if you walk out of here Thursday and go, I know all of this stuff, you go ahead and take the test. Is that clear for everybody now? Although I'm not going to change it on the calendar. The calendar is still going to show it's from Monday through Friday next week. I'll send you a note and tell you it's open and available. I'm not going to go in and try to change that one. Also still got to get all y'all's grades transferred several times over the next 2 weeks. I've got to get them finished in another class, in the online class, plus the 2453 test out. I've still got to be transferring grades, and I've got several other things to be doing on all of that, and I've got to get work ethics done for some classes in the next week, so it gets busy from this point on out. And then some of you may have read the email from me this morning that said on Tuesday, Wednesday last week, and again headed towards this week, that it was Monday night, and then I've still got tonight and tomorrow night, but it won't be tonight. That getting the lectures done has been taking me on the nights where I've got the 3 classes to do. Like last night, that it took me 4 hours to get them all fixed and posted out there. Tonight, I doubt if I get y'all's posted out there, because I've got a meeting up in Hickson this evening, and by the time I get home from that one, I'm probably not going to even try to fool with it. But if I did post anything of the lecture, it'd just be the teacher cue one, because it would not, I wouldn't get the conversion to the movie done and posted out on YouTube, and that takes over an hour or so to do. The conversion, and then uploading is quick and easy. TeacherTube takes longer to upload it out there, but uploading to YouTube, it immediately gives me my feedback of what the address is for me to put a Blackboard immediately there while it's still uploading, and then it takes 10 minutes or so for it to do the upload, process it, and post it out there. But it's on out there without me having to fool with all that. TeacherTube, I have to sit there and wait for it to upload, and then I put in information about it, and it comes back immediately and tells me what the URL is, and I can put it in Blackboard. So the two of them work differently. But the other part is with TeacherTube, I just got to go in and look straight at the file on there when I've transferred it to my machine and stick it in Cool Edit off the front and back end, and then I can put that into Movie Maker, along with having created a little paint file that just got to go with it to then convert it to a movie. And that takes over an hour to run that conversion process. And it is working my machine doing it, because my video card hollers the whole time. That I have a low beep going on the whole time, because I'm maxing out that video card. I've got another video card to put in it, but I've got to find time to where I can shut down my machine and pull it out and stick that card in, and then bring it back up and make sure I got the right drivers and everything installed. And it's got bigger processor and more memory on the video card. And then I shouldn't have to listen to it scream at me all the time I'm doing my audio editing. Any questions? Then I will see y'all on Thursday. And that you'll have that there. And so then next week we'll just be working on the wiring. So if we get it done on Tuesday, we'll skip out on Thursday.